Okay, what you're going to find is the grade 12 course mirrors the grade 11 course in that the units that we do are very similar. So in our first unit we did kinematics. Now that's the study of motion, and then we branched off into dynamics, which is forces, which you cover in grade 11. So forces cause the motion to occur. What we're doing in Unit 3 is we're doing energy and momentum. So you're going to find a little bit of review in the first couple of lessons here as we move forward. So to understand energy, we first must understand work. Now, be aware that when you define energy, you use the term work, and when you define work, you use the term energy. So they're often used synonymously. Work is just a change in energy that's occurring. So our formula for work, which you would have studied in grade 11, is work equals force times distance. Remember that force is measured in newtons, and force is just mass times acceleration. And we need to have a distance to do work. So you can push on a rock all you want, but if that rock does not work, you have not done any, if that rock does not move, you have not done any work. Now remember, we do have something that is scalar here. So we do have a direction involved in this. So you must say what direction you are going in. Now, what we get when we do work is Newton meters, which we have a measurement called joules. So I think a tough thing here is we can all understand what degrees Celsius is. So if you say you have to go outside and it's 24 degrees Celsius, that makes sense to you. But what is a joule? Imagine grabbing a 2 kilogram weight that's around 5 pounds and lifting that up over your head by 1 meter. If you move that 2 kilograms by 1 meter, that's equivalent to a joule. Remember, when we're doing work problems, direction's important, so we have to be able to work this into our equation. So if you're pulling a cart, so if you're standing there and you're pulling a cart and you're doing it at an angle of 45 degrees, not all of that force is being put in the direction you're going in. So you want to pull it this way in the positive or easterly direction. So you have to take the cos of 45 degrees to transfer this force right here into this vector. So let's more accurately say that work equals cos of an angle force times distance. So we've got the cos of 45 degrees times our force, which is 49 newtons, times the distance, which, or displacement, I have 10 meters here. So that would be 0.7, approximately, it's 0.707, times the 49 newtons times the displacement of 10, which would be 7 times 10 approximately, or 70 joules. Now, interestingly, if you pull straight, so we're pulling at an angle of 45 degrees here, if you pull straight, your angle is 0. The cos of 0 is 1. Okay, we don't have to do the angle if we're pulling straight in the x vector here in the x direction, but the cos of 0 would be 1. If we were pulling backwards, the cos of 180 is minus 1. What's your direction? You're going in a negative direction there. Now, I think the example problems are really important in U3A1. Make sure you go through all of them in detail, because they talk a little bit about how to deal with forces as you're doing these problems. These are the basics of what you have to get out of U3A1. I don't think there's too many tricks in the problems. I think you'll find them pretty straightforward. Once again, if you ever have a problem understanding a concept, just get in touch with me.